Okay, so we have a question here. It says a pharmaceutical company is testing a new drug for flu treatment. The probability that a randomly chosen patient recovers within 3 days after taking the drug is 0.75. If five patients take the drug, A, what is the probability that exactly three of them recover within 3 days? B, what is the probability that at least four recover? And C, what assumption about the recovery process allows you to use the binomial distribution in this scenario? So this question says, this is a binomial distribution experiment. This is based on probability. If you remember, probability is the likelihood that something is going to occur. That's the definition of probability. Now, in a binomial distribution, it's like you're conducting a test and there are only two outcomes. Okay? Only two outcomes. The outcomes are referred to either as a success or a failure. It's dependent on what you are examining for you to determine what is a success and what is a failure. So in this question here, we've only got two outcomes. It's either you recover within 3 days or you don't recover within 3 days. Okay, those are the two outcomes. So in this case, a success is if you recover within 3 days. All right, if you recover within 3 days for this experiment, that's a success. If you don't recover within 3 days, then that is a failure. Okay, so we're going to look at first part A. All right, want to find out what is the probability that exactly three of the people who take this drug, okay, recover within 3 days. So let me just get down the formula for a binomial distribution. So this is the formula of a binomial distribution. I'm going to say what everything means in this formula. Okay, let me just rewrite it so it looks better. Then I'll explain what each term or what each letter means. So this formula, you do not need to memorize it. Okay, it's given to you in your exams. Okay, it's given to you in the exams. Okay, so in this formula, n represents the number of people, the number of people in the experiment, right? So in this case here, we said there's a total of 5 patients or 5 people who this experiment is being conducted with, all right? They told us if 5 patients take the drug, so it means the total number of people in this experiment is 5. P represents the probability of the success. Okay, let's say it here. It says the probability that a randomly chosen patient recovers within 3 days after taking the drug is 0.75. So P is the probability 0.75. Q represents the probability of the failure. Okay, so this is the probability that if the person takes the drug, they do not recover within 3 days. So remember, according to the rules of probability, okay, when you're adding up probabilities, they have to total up to 1. That 1 represents 100%. Okay, so here we already have the probability of a success. We want to find what's the probability of the failure, meaning the person doesn't recover within 3 days. So you say P plus Q equals 1. So we already have the probability of the person getting cured, 0.5. And we want to find Q. So Q equals 1 minus 0.75. So we get 0.25. So the probability if a person is chosen at random and takes the drug and it doesn't get cured within 3 days is 0.25 or 25%. Are there any questions before I move further? Any questions? Okay. Now, we want to find what is the probability that exactly 3 patients recover within 3 days. So, in this case, our X is going to represent 3 people. Okay. Exactly 3 people. So, X in this case here is going to be replaced by 3. So, it's just a matter of substitution into the formula. N, we have 5, so this is 5 factorial divided by n minus x, so that is 5 minus 3 factorial. X here again, this is a 3 factorial multiplied by our probability of a success, 0.75 to the power x. So we're going to say 0.75 to the power 3 since x equals 3 multiplied by q, which is probability of a failure, 0.25 to the power n, which is 5 minus 3. Okay, so remember with factorials, for example, 5 factorial is the same as saying 5 times 4 times 3 times 2 times 1. Okay, 3 factorial is the same as saying 3 times 2 times 1. Okay, on your calculator, the factorial symbol is there. It's just this exclamation mark. That is the factorial symbol. Okay, so if we simplify this is going to be 5 factorial over 5 minus 3, that is 2 factorial over 3 factorial multiplied by 0.75 to the power 3 multiplied by 0.25 to the power 2. Okay, so now we solve each part individually, right? So 5 factorial, instead of doing all these multiplications, here's a shortcut that you can do. Okay, you can just say, if you can say, okay, want to also get rid of this 3 factorial at the denominator. Hello, sir. The class is being recorded. Okay, so let me just finish the recording. Then you ask question. I'll explain what is happening. Just follow along. Then I'll re-explain what is happening. But we're looking at this question here for this one for this question here. A pharmaceutical company is testing for a new drug for a flu treatment. Probability that a randomly chosen patient recovers within 3 days after taking the drug is 0.75. If 5 patients take the drug, this is the question that we're looking at. So it's on the topic of probability, binomial distribution to be specific. And as I said, a binomial distribution is a type of test where you have only got two outcomes. Okay. So in this case here, for this question here, there are only two outcomes. The first outcome is either the patient takes this drug for flu treatment and recovers after 3 days, or the person takes this drug and doesn't recover after 3 days. So there are only two outcomes for this experiment. If you remember the definition of probability, probability is the likelihood that something can happen. Okay, the likelihood of an event occurring. Okay, so this question is dealing with the binomial distribution, and this is the formula here for the binomial distribution here. Okay, you don't need to memorize it, but you need to understand what each element means. So I'll explain to you what each element in the formula means. N represents the total number of participants in the experiment. They've told us in this question if 5 patients take the drug. So in this experiment, we got 5 patients, total of 5 patients. P represents the probability of a success. A binomial distribution, as I said, is got two outcomes. So the outcomes are labeled either a success or it's labeled as a failure. Yes, the outcomes, as I said, there are two outcomes. The outcomes are either a success or a failure. Okay, so P represents the probability of the success. Okay, in this context, hello, I'm in a class. Call me after some time. Right, sorry about that. Yes, so I said the probability. P is the probability of a success. Okay, then Q is the probability of the failure. So in this context, the success is you're getting cured after taking this drug. And then the failure is you take this drug and you are not cured. Is that okay, sir? Okay. So in the question, they've told us the probability of, as this is, if a person is randomly chosen, let me read it here. It says, the probability that a randomly chosen patient recovers within 3 days after taking the drug is 0.75. So this is the probability of a success. Now remember, probabilities add up to 1. So the probability of recovering is 0.75 or 75%. Then the probability of not recovering is 25%. Okay, because percentages end up to 100. That's why we say probabilities end up to 1. That 1 can also represent 100%. Okay, so if the probability of recovering is 75%, then the probability of not recovering is 25%. That's how we got this Q equals 0.25. Are we okay with that, sir? Okay. So um, this is the formula here, as I said. So it's just a matter of substitution. N is 5. In the question, it says, what is the probability that exactly 3 of them recover within 3 days? Okay, so X is going to be 3. Okay, your value of X is going to be dependent on what the question is saying. Okay, so X is 3. So as you can see, 5 factorial over 5 minus 3 factorial, 3 factorial multiplied by 0.75 to the power 3. You can see P to the power X, 0.75 to the power 3. And here Q, 0.25 to the power N minus X. So here to the power 5 minus 3. Okay. So we've substituted all the numbers into the formula. So here we've done 5 minus 3, we get a 2 factorial here. 5 minus 3 again, here it's 2, so we have 0.25 to the power 2 here. So we now want to solve here. Basically, we're now starting to solve. So factorials is just a counting method. So when you see 5 factorial, it means 5 times 4 times 3 times 2 times 1. Then 3 factorial, 3 times 2 times 1. Okay, then 2 factorial is the same as 2 times 1. Okay, so one way we can do it here, okay, we can just say, okay, 5 times 4, that is 20. 20 times 3, that is 60. 60 times 2, that is 120. 120 times 1, that's 120. Divided by 2 factorial, 2 times 1, that is 2. Do not multiply 2 times 3 and say 6 factorial. No, you leave them as they are. So 2 factorial is the same as 2 because it's just 2 times 1. Then 3 factorial is 3 times 2 times 1. That gives us 6. Just get your calculator, sir. What is 0.75 to the power 3? 0.42. We'll just leave it as 0.421. Okay, then 0.25 squared. 0.062. 5. Okay. Then 120 divided by 12, that is 10, right? 120. Yeah. So here we put 10. Okay. So 10 times 0.421 times 0.0625, what do we get? 0.2631. Okay, that's the probability that when no, when 3 patients take this medicine, they get cured. Okay, within 3 days. So it's the same as 26.31%. Any questions? Okay, we're going to now part B. What is the probability that at least 4 recover? So here, when you hear the word at least, it means the minimum has to be 4 people recover, right? When they say that at least 4 recover, it means the minimum number of people that must recover is 4, right? Yes. So now remember we have got 5 patients, 5 people we are observing. Okay. So first, this is how we're going to write it: x greater than or equal to 4. Okay. This means that at least 4 people recover. So what this means, okay, is basically we're saying we're interested in the probability that exactly 4 recover plus the probability that 5 recover. Because remember, we have a total of 5 participants. So when we say at least 4 recovering, it can also mean even 5 can recover because 4 is just the minimum number. Okay, so it also includes the probability that even 5 patients recover. Are we okay with this? What has happened here? Okay. So again, we have to find these probabilities individually so that then we total them up. Okay. So back to the formula here. Let me highlight. So the only thing that's going to change in our formula is x. N stays the same as 5. P stays the same as 0.75. Q stays the same as 0.25. It's only x that changes its value. So when we replace in our formula, P x equals 4 equals 5 factorial over n minus x of 5 minus 4 factorial. Then x here again we have 4 factorial. Just mute your mic so that clear and audible to everybody. Multiplied by, so we say here 0.75. Now remember here in the formula it's p to the power x. So it's going to be 0.75 to the power 4. Multiplied by q. So here q is 0.25 to the power n minus x. So n is 5, x is 4. So 5 minus 4, that is 1. So it is 0.25 to the power 1. When we subtract here 5 minus 4 factorial, that is 1 factorial. So here we have 5 factorial over 1 factorial, 4 factorial. Okay, so we can easily solve this one. 5 times, we end here at 4 factorial, so that the factorials cancel each other out. 1 factorial is the same as 1. So this 4 factorial at the bottom and this one at the top cancel each other out. Okay, this is one shortcut you can use when you're solving these factorials. Okay, just get rid of the one denominator factorial. Okay, as you can see, I did 5 times, then I ended at 4 factorial, so that I get rid of this 4 factorial. Okay, so 5 divided by 1, that is just 5. Okay, so when we simplify 5 factorial over 1 factorial, 4 factorial, your answer comes down to 5. Are we all okay with how I did that? Okay. On your calculator, what is 0.75 to the power 4? 0.3164. Okay, 0.25 to the power 1 is just the same as 0.25. Yes. So 5 times 0.3164 times 0.25, what do we get? 0.3955. All right. Then we have to get the probability also that 5 people recover. So P x equals 5. So you have 5 factorial over, remember we're just following the formula, okay? Where there's n, we put 5 over n minus x. So in this case, our x is 5, so it's over 5 minus 5 factorial, then x factorial here, so you put again 5 factorial, multiplied by, okay, here we have p, which is 0.75, okay, p to the power x, so 0.75 to the power 5, because our x is 5, so 0.75 to the power 5 multiplied by q, which is 0.25, to the power n minus x, so to the power 5 minus 5. 5 minus 5, that is 0. So here we have 5 factorial over 5 minus 5, that is 0 factorial. Now, colleagues, 0 factorial equals 1, okay? If you type in your calculator 0 factorial, you are going to see your calculator will give you 1, okay? So here, this 0 factorial is 1. This 5 factorial and this 5 factorial cancel each other out. So it's basically 1 over 1. So when we do this tabulation here, our resultant answer is going to be 1. Okay. 0 factorial equals 1. The 5 factorials cancel each other out. 5 factorial divided by 5 factorial, that you get 1. So our overall answer here is 1. Are we okay with that, colleagues? Any questions? Okay, 0.75 to the power 5, what is it? 0.2373. Then 0.25 to the power 0, that is 1. So when we multiply out, we get 0.2373. Okay. So now I want to get the probability that at least 4 people get cured. Okay. So that includes the probability that exactly 4 people get cured, which is 0.3955, plus the probability that 5 get cured, that is 0.2373. So when we add 0.3955 plus 0.2373, what do we get? 0.20. What is it? Okay, yes, which is the same as 63.28%. So that's the probability that at least 4 people get cured. Any questions or queries before we go to part C? Okay, part C of the question. So I wrote the notes down for part C, but let me read it out first. What assumption about the recovery process allows you to use the binomial distribution for this scenario? So here it is. First condition of a binomial distribution is there has to be a fixed number of trials. In terms of, when we say a trial here, we're meaning the number of people basically, or the number of objects, whatever you're investigating. Okay, so here there's a fixed number of patients, which is 5. Okay, and that's the first condition of a binomial distribution. Fixed number of trials, that's be a fixed number of people being who the experiment is being done on. Condition number 2, there must be independent outcomes, meaning the recovery of one patient shouldn't affect the recovery of another patient. Each patient's recovery should be independent. The recoveries are not dependent on each other, basically. Condition number 3, each patient has 2 possible outcomes. As I said, with the binomial distribution, there always has to be two possible outcomes. Okay. So the two possible outcomes are either you recover within 3 days, which, as I said earlier on, is a success, or you do not recover within 3 days, which is a failure. And the final condition, there has to be a constant probability of success, meaning for each of these 5 patients, the probability of them getting cured should all be 0.75. Not one has a probability of 0.75, the other one 0.45, the other one 0.35. No. Everyone who's taking part in this experiment, the probability of recovering should be the same, okay, which is 0.75, which was given to us in the question. Okay, so these are the 4 conditions that you need for a binomial distribution